Namaste everyone and welcome to Code with Professor. I am your host and today we are embarking on an exciting journey to understand one of the most fundamental concepts in database management, SQL Joins, and how we can use them effectively with Java. If you have ever wondered how to combine information from different tables in your database, this tutorial is for you. By the end of this 5-minute video, you will clearly understand what SQL joins are, why they are essential, and how to implement them in your Java applications using Java Database Connectivity, or JDBC. We will cover the core concepts, look at practical Java code examples, and even discuss some common mistakes to avoid. So, let us dive right in and unlock the power of connected data. Alright, let us start with the very first type of join, the inner join. Imagine you have to separate lists, say, a list of employees and a list of departments. Each employee works in a specific department. An inner join is like finding all the employees who are actually assigned to a department that exists in your department's list. It only returns rows where there is a match in both tables based on a specified condition. Think of it as the intersection of two sets in mathematics. If an employee does not have a matching department, or a department has no employees, they will not appear in the result. It is perfect for getting precisely the common data. In Java, after setting up your database connection, you would create a statement object, then execute a query like select employees.name, departments.department_name from employees inner join departments on employees.department_id is equal to departments.id. The result set will then contain only the matching records. Next, we have the left join, sometimes also called a left outer join. This join is a bit more inclusive than the inner join. With a left join, you get all the records from the left table, which is the first table mentioned in your from clause, and only the matching records from the right table. If there is no match for a record in the left table, the columns from the right table will simply show a null value. This is incredibly useful when you want to see all entries from one table, even if they do not have corresponding entries in the other. For example, if you want to see all employees, including those who might not yet be assigned to a department, a left join is your friend. In our Java application, the approach remains similar. You would just change your SQL query to select employees.name, departments.department_name from employees left join departments on employees.department_id is equal to departments.id. and then process the result set just as before. Notice how simple it is to switch between join types in SQL and Java. Now, let us bring it all together with a practical Java example. Here, we have a simple Java program that connects to a database, executes an inner join query, and then prints the combined data. First, we establish a database connection using driverManager.getConnection. Remember to replace the placeholder for your database URL, username, and password. Then, we create a statement object to execute our SQL query. Our query, select e.name, d.department_name from employees e inner join departments d on e.department_id is equal to d.id, uses aliases e for employees and D for departments to make it shorter and clearer. The results are stored in a result set, which we then iterate through using a while resultSet.next loop. Inside the loop, we retrieve column values using resultSet.getString and print them. Finally, and very importantly, we close all our resources like the resultSet statement and connection in a finally block to prevent resource leaks. This complete structure ensures your Java application correctly fetches and displays joined data. While working with SQL joins in Java, beginners often make a few common mistakes. One frequent error is forgetting the ON clause in your join statement. Without it, the database might perform a Cartesian product, which combines every row from the first table with every row from the second, leading to a massive and incorrect result. Another common pitfall is not using prepared statement for queries that involve user input. This makes your application vulnerable to SQL injection attacks. Always use prepared statement to set parameters safely. Also, remember to close your database resources like connection statement and result set properly. Not doing so can lead to resource leaks and performance issues. A best practice in Java is to use the try-with-resources statement, which automatically closes these resources for you, making your code cleaner and more robust. Always alias your tables in complex queries for better readability and maintainability. And there you have it, future Java developers. We have covered the essentials of SQL joins and how to integrate them seamlessly into your Java applications. We started by understanding what joins are and why they are crucial for combining related data. We then explored the inner join, which gives us only the matching records, and the left join, which retrieves all records from the left table along with matching ones from the right. We also walked through a complete Java database connectivity example to see these joins in action and discussed important best practices and common mistakes to avoid. Remember, practice is key. Try creating your own simple database tables and experiment with different join types and Java code. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to Code with Professor for more insightful Java programming tutorials. Keep coding, and I will see you in the next video.